So number 36, we have 5 long parallel wires in an XY plane are separated by a distance of 8 centimeters, have length of 10 meters, and carry identical currents of 3 amps out of the page. Each wire experiences a magnetic force due to the currents in the other wires. In unit vector notation, what's the net magnetic force on wire 1, 2, 3, 4, and 5? All right. First of all, if you double check with your right hand rule, remember that each one of these wires is going to have a magnetic field, since the current's going out of the page, pointing around this direction, going around anti-clockwise or counterclockwise. That's going to produce a net magnetic field at the presence of wire 1 pointing downward, sort of like this. And then if you double check your current field force for wire 1, currents out of the page, magnetic field downward, it's going to produce a force to the right. Whoa, I did all this work. I forgot to put the arrow on. Quick reminder, with Ampere's law, magnetic field around a current carrying wire is just given by this expression. So what's the net magnetic field due to these other wires? Well, here is the magnetic field due to wire 2. It's 8 centimeters away, carrying 3 amps. Here is the magnetic field due to wire number 3. It's 16 centimeters away. And here's the magnetic field due to wire 4. It's 24 centimeters away. And here's the magnetic field due to, finally, wire 5. If you add those all up, you find the total magnetic field acting at the position of wire 1 is this. How do we figure out the force? Well, there's the force vector finally. We're going to use IL cross B. The current in wire 1 is 3 amps, its length is 10 meters, and the magnetic field at its position is the answer we just got up here. Plugging that in, we'll discover the force on wire 1 is 4.69 times 10 to the minus 4 newtons. And since it's pointing in the positive y direction, and they wanted this in unit vector notation, we'll add a little j hat at the end of this. What about wire B? Well, wire B is going to have a force in the same direction, but there's something interesting going on here. If you think about the magnetic field around wire 1, it's going, again, anti-clockwise, but it's going to produce a magnetic field that's pointing upward here, whereas wires 3, 4, and 5 are going to produce fields that are pointing downward. You might notice already that the field due to 1 and 3 are going to basically cancel out, but we'll write it in here. But what I'm going to do is I'm going to say that this is a negative value for wire 1. And I'm going to call the magnetic field due to this wire positive. I could have made this one positive and all these negatives, or made them all negatives up here. Arbitrary choice on my part. And the magnetic field's the other 2 wires. I won't draw brackets around it this time. Gives us that. Plugging into IL cross B, we get a force of roughly that. What about wire 3? And some of you might have already guessed it. Take a look at it. What's going to happen for wire 3? Well, you've got wires 1 and 2 producing a field that's around themselves counterclockwise, same thing as those. At the position of wire 3, these 2 are going to produce magnetic, 1 and 2 are going to produce a field that way, 4 and 5 are going to produce a field that way. And I'll do the math on it real quick, but you can sort of see it ahead of time. What's the total magnetic field due to the other wires at the position of wire 3? The answer is 0. Plugging it in is kind of trivial, but I just want to do it, 0 newtons. And I won't even put a direction on this one because it's kind of trivial. Then finally, what about wires 4 and 5? You're like, oh my goodness, this is a long problem. It is in some ways, but also you might notice that for wire 4, it's almost exactly the same situation as we had for wire 2. In other words, the magnetic field now for wires 3 and 5 are going to cancel out, leaving just the magnetic field due to these 2. Overall, it's going to produce a magnetic field that's pointing upward. If you do your current field force, you'll discover the force on wire 4 is over towards the left. What's the magnetic field, or the force? I'm not going to do all the math again because wire 4 is just like wire 2, which we just did right here in B. It's the exact same magnitude. Whoops, they're out of order. Sorry. Exact same magnitude as this one, except negative, because it's now pointing in the negative y direction or the negative j hat direction. Finally, you can already see the answer on this one that's out of order. Um, wire 5 is going to be just like wire 1, just beautiful symmetry involved here. So it's going to have the exact same magnitude as this one, it's just pointing in the opposite direction. So negative, same answer, j hat. Hopefully this makes sense.